Okay, now we have section 9.5. We're going to talk about common logs and natural logs. The first thing I want you to do is do this warm-up and use your calculator and round to 4 decimal places. As you can see, there are things like E, log, and this is an ln. Here are where the buttons are located. E is above this division sign. So you do second divided, and there's a little E right there. The log buttons are on the left. This one says log, and then this one says ln. That's called the natural log. ln stands for natural log. So I'm going to be checking this, just round to 4 decimal places. The next thing we're going to talk about is the common interest formula, and this is, well, it's called common because it is the most common formula you'll use, because technically when you have a savings account or a credit card or anything like that that accrues interest or charges you interest, it's compounded so many times per year. For example, if it's compounded monthly, then that's saying that your savings account at the end of each month earns a bit of interest. If it was just compounded one time per year, yearly, that'd be at the end of the year. And credit cards and savings accounts are both compounded monthly. Sometimes you'll have like a retirement account that'll be compounded quarterly. And quarterly, as you know, there's 4 quarters in a dollar, and quarterly is represented by 4s, so then it's 4 times per year. So every 3 months, they would take that value, plug it into this equation, and add that amount of interest on. Okay? Then your rate is obviously as a decimal. Another thing that you need to know is this E business. You saw E in the warm-up. E is just a number. It's very similar to pi. It's an irrational number that goes on forever. And you can just push that button right on your calculator, and you'll see E is about 2.718. So the first thing I want you to do is find the natural log of 53, ln of 53, and the log base E of 53. And if you recall, to type this in your calculator, you just hit ln of 53. To type this, you need to use the change of base formula, which is log of the base, the big number, over log of the little, the base. Log of 53 over log of E. So go ahead and tell me what's true about those two numbers on that line. Okay? I don't know why we number 6. We're at number 1 is if I want to find log base 5 of 8. Again, use that change of base formula. Log of 8 over log of 5, and type that in your calculator. Please do these. Each time I say this, make sure you have your calculator with you and you do that. Oops. 1.2920. And if you're not getting that, you need to come in and see me or ask a question during class. Number 2, log base 4 of 31. Go ahead and do that. The next thing I want you to do is graph 2 graphs on the same plane. And feel free to use your calculator. That would probably be a really good idea. If you don't have a calculator and you're sitting at home taking these notes, then when you come into class, the first thing you should be doing is going through and doing this, because you already have the notes copied, you'll already have your coordinate plane drawn, and now you'll just go ahead and get those graphs done. I also want to make a t-table. And if you type these in your calculator, you will see that your x values, the same numbers that we usually use, -1, -2, 0, 1, and 2. And then get your e to the x values and your e to the negative x. And I want to see that graph right here. Then I also want you to talk about what is the domain and the range. The domain and the range are the same for both of these graphs. That should be a hint. It's not, the domain and range aren't the same as each other, but this graph and this graph have the same domain, and this graph and this graph have the same range. Okay? Graph. So the next thing we're going to do, and I'll go through these with you, is we're going to graph them. We're going to find the domain and the range. And we're going to describe the shift. So we have f of x equals e to the negative x plus 2. So if you want to just type that into your calculator, I'll show you how to type it. I don't know if you can see this very well, but you type the e to the button is down here if you'd like to use that, or you could just use the e and then the caret. So I have e to the negative x, close the parentheses, and then the plus 2 is outside of that. It's a pretty good picture. So you'll see, and as you saw from your e to the negative x, is that this asymptote that it's approaching was approaching 0, like the log functions we talked about before. Now it's approaching 2. Look at the t-table. As we increase our value, look at these, they are getting closer and closer to 2. The calculator then says, okay, fine, it's 2. Remember, that's one of the lies the calculator tells you. That is not true. It's going to say 2 forever now, but really it's like 2.0 with a million zeros and then a 1. Okay, so go ahead and sketch that graph. There's a point 0, 3, and here's a rough sketch, but I would always draw the horizontal asymptote if you can, because it shows you basically this axis that was the asymptote is shifted up 2 units. So the shift is up 2, the domain and the range. Now if you were having a problem on the last problem when I asked you to do domain and range, watch this explanation. The domain is left to right. So this goes forever to the left and forever to the right. So the domain is all real numbers. And now the range goes bottom. Where's the first number it starts? Well, the calculator says it starts at 2. But remember, it doesn't exactly start at 2, so you use a parenthesis because it's really just above 2. And then where does it stop? If it continues going up forever, it stops at infinity. So that should kind of clear up some of that. If you're graphing just the natural log of x, you can type it in your calculator. Let's see, can you see that? Just the ln of x and graph. And now you see right here, you have a little bit of an issue. You don't know exactly what's happening. Well, if I zoomed in, say on that spot, okay, you can see that it's getting closer. And if I zoomed in again, I'm just moving my cursor down to zoom in at the bottom. You can see it's getting closer. And as you zoom in, you're going to keep seeing pictures like that. Because here we have what kind of asymptote? A vertical asymptote. If you make your t-table, you'll see that 1, 0 is a point, and then again, at 0, there's nothing. And so here, your calculator understands vertical asymptotes a little better. They won't necessarily lie. But it is approaching this asymptote. It's getting closer and closer and closer. So the domain, where does it start? Going left to right, it starts at 0 to infinity. And the range here, it goes down forever and up forever is all real numbers. Now remember, these e to the x and ln of x are inverses of each other. So the domains and ranges typically switch. Obviously in this case there was a shift, but other than that. Now we're going to look at the ln of the quantity x plus 3. So here we didn't have the 2 in the exponent with the x, but here we have the x plus 3 together. So this will not be an up-down shift. This will be a left or right shift. So plug it in your calculator. And then you see something like this. Now again, your calculator does not know what to do here. So it looks like it just stops. Really, it continues down and it's approaching this vertical asymptote. Because ln functions have vertical asymptotes and exponential functions have horizontal asymptotes. So where is this shifted from our, we can regraph the ln of x. So if this is the original, we shifted now left. How many units? 3. Domain and range. The domain now starts at, doesn't start at 0, it starts at -3 to infinity, and the range again is all real numbers. And this is just a rough sketch. This does not approach a horizontal asymptote. It does flatten out, but it does keep increasing forever and ever. There's only one asymptote on these. Okay? So that's 9.5. You need to start understanding, though. Expect to see some of these problems and be able to do them. At least the generic graph, you should be able to get this without a calculator from this, knowing that there's a left shift. So you might want to start memorizing some of the e to the x, e to the negative x, ln of negative x functions. That is your fair warning.